Hello techies, welcome to Tech Blooms. In this video we'll be doing about demux and we will be seeing the difference between mux and demux, and also I'll be designing a 1:4 and 1:8 mux here, and we'll be deriving the expressions from the truth table, as well as we will be doing the combinational logic for demux. So let's begin. If you are new to my channel, please do subscribe to my channel and don't forget to click the bell icon for latest updates. So let's begin. Now here what I will be doing is that first I will explain you the difference between the mux and demux. So now we have a mux. Mux is basically we have a several inputs. Mux has several inputs and one output, right? Now this input is mapped over to this output. Yes. So but in case of with respect to the select lines, but in case of demux, what is that? It's just the opposite of mux. What happens is that we have a single input, also called as a data input, and that input is given to all other outputs on basis of your select lines. Okay, so this is the basic difference between mux and demux, and overall there will be an enable pin. Okay, in both the cases enable, or in some cases it is called as strobe also, and this is the output. These are the select lines and this is the input, and here it is the select lines, input, output. So your mux is a several input single output combinational logic, and whereas you have demux, which is a single input and several output combinational logic. So now let's look at 1:4 and 1:8 demux. So now here we'll draw a 1:4 mux. 1:4 is in the sense what it indicates. We have a single input, that is the data pin, and we have 4 outputs, 3, 4. I will name them as y0, y1, y2, y3, and since it is 4 outputs, you will have, how do we select? We have here the number of select lines is selected based on this formula, that is 2 raised to m is equal to n, where n is the outputs, where n is the output, n output, you have m select lines, and you have input lines. Now here your m is how we need to get. Now what we know, n, that is 4, so 2 raised to 2 will be 4, so you have 2 select lines. So let's write your select lines as S0 and S1. Okay, S0, S1. So now these are my select lines and these are my output lines and this is my input line. So let's draw the truth table for this. Now how we get the truth table? We have the inputs, that is the data pin. Okay, data pin, and we have the output, that is y0, y1, y2, y3. Okay, and your select lines. Now data, we are basically we are giving data as the single pin. Now you have a data as a single pin, so it will be going to y0, where depending upon your select line. So we'll give input as the select line, that is S0, S1. Okay, now this is your the truth table. Now we have combination, that is 0 to 0, 0 1, 1 0, 1 1. Now these are the combinations, right? Now when you have 0 0, what will happen? The data pin will be connected to y0. Data pin will be connected to y0. So your data will be here and remaining these pins will be 0 depending upon your strobe. Now here you can have enable also. Depending upon your enable, you will have your demux will be activated or unactivated. Now when you have 0 1, this connection will be given, this data will be passed to y1. So here you will have 0, here you will have 1, 0, 0. So when you have the other combination, that is 1 0, your data line will be passed to y2. So your y2 will have a data and remaining pins will be 0. And for 1 1, your output will point to where your data pin will point to your y3, and you have all zeros except the y3. Now here you have the data point, 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 right? Now from this truth table, can we get the expression? Yes, we can get the expression as in, now y0, now you can see this y0, right? Y0 can be written as, it is only at the output is present only at 0 0 combination. So we can say that it is S1, S0, both are having pass. So S1 bar, S0 bar. As I am indicating that 0 is has a bar, I am indicating, and 1 I am taking as without bar. 0 is complement and 1 is without complement. So here you can see now S0 bar, S1 bar will give you Y0. So in similar lines we have Y1 which will be equal to S1 bar S0, because S0 is 1 and S1 bar is 0. Then we have Y2 in similar basis as S1 S0 bar, and we have Y3 which is S1 S0 or S0. So now this is how we get the expression for your demux, that is 1:4 demux, 1:4 demux. Now depending upon these expressions whichever we have got from the truth table, we can draw the structure of this demux using logical gates. So let's look at that. I will be keeping this equations here. Let me erase this. Y0, Y1, Y2, Y3 as the output pins. We have the inputs S1 bar, S0 bar. Okay, and there is one data pin. Now we will keep the data pin as here. A line as a data pin. Okay, we'll give this as a data D. Then we'll have S1. And this S1, we will give it to a NOT gate to create a S0. And we have S1 bar, and we have S0, and we have here S0 bar. Now this is basically AND, right? So now when we will get Y0, when we have S1 bar, S0 bar. When we have S1 bar, S1 bar, S0 bar, we get our Y0. Now next case is when we get Y1, that is S1 bar and S0. You get your Y1. In similar lines, when we have S1 and S0, S1 and S0 bar, we get Y2. And where S1 and S0, we get Y3. So this data pin will be going to all of this. So this is how you can enable them. From this truth table, I have derived the equations, and from the equations I have constructed a demux using logical gates. Now this is how we do the demux. Now this is 1:4 demux. Hope you understood this video. Please do like, share and subscribe. Thank you.